Have you ever wondered what truly generates the electric push from a solar panel, the invisible force that drives electrons through a circuit? It is a fascinating process that relies on fundamental physics. The role of charge accumulation in photovoltaic voltage is absolutely central. Photovoltaic voltage arises directly from the separation and buildup of positive and negative charges on opposite sides of a semiconductor junction within a solar cell. This phenomenon occurs due to the unique properties of a p-n junction, formed by joining p-type and n-type semiconductor materials. When photons from sunlight strike the cell, they excite electrons, creating electron-hole pairs. The inherent electric field across the p-n junction then acts like a microscopic separator, sweeping free electrons to the n side and holes to the p side. This directed movement prevents immediate recombination and causes these separated charges to accumulate. Understanding this core principle allows engineers to optimize solar cell design for maximum efficiency. For example, by carefully controlling doping levels and junction thickness, one can enhance the electric field strength, which in turn improves charge separation and accumulation. This directly influences the open circuit voltage and overall power output of the device. It is not just about generating charges. It is about effectively segregating them to create a usable potential difference. This accumulation of charges creates an electrostatic potential difference, much like a tiny battery waiting to be discharged. The open circuit voltage, or VOC, of a solar cell is a direct measure of this built-up potential before any current is drawn. Moreover, the band gap energy of the semiconductor material places an intrinsic limit on the maximum voltage that can be achieved, as it dictates the minimum energy photons requiring to create these charge carriers. Silicon, for instance, has a band gap that allows for efficient conversion of a broad spectrum of sunlight. Ultimately, the efficient accumulation of separated charges is the very essence of how a solar cell converts light energy into electrical energy. It is the critical mechanism that creates the electromotive force necessary to drive current through an external load, turning photons into usable power for our homes and devices.